morning. My name is Daanyaal Kapery. My research topic is modeling sustainable insulations for concrete printed walls. For my presentation, I'll run through an introduction, some literature, methodology, results, and then end off with my conclusion. Some background of 3D printing of concrete, which I'll refer to as 3D PC. 3D PC offers a more environmentally conscious method by enhancing material efficiency, reducing construction time, and provides the opportunity to integrate eco-friendly and recycled materials into the concrete mixture. Heating, ventilation, and air conditioning systems are essential when designing buildings. However, these systems are major contributors to greenhouse gas emissions. These systems are difficult to eliminate because they provide optimal thermal comfort. Therefore, it is important to reduce these systems through measures to further contribute to the sustainability of the 3D PC industry. The energy consumption of heating, ventilation, and air conditioning systems can be reduced by modeling 3D PC structures with sustainable insulations. The aim of my project was to identify and investigate insulation materials that can be sprayed by an automated system within the cavity of a double-leaf concrete printed wall. The material had to be sustainable, cost-effective, and sprayable. Due to the limited time of my project, limitations had to be set. These are a single 3D piece material, a fixed wall geometry, a fixed surface texture and color, and thermal environment from one selected region. Here's an image which depicts an example of a 3D PC structure, a double leaf wall with a cavity at the center and precision wall ties. The performance of an insulation is measured by the ability to resist heat flow. Thus, the three fundamentals of heat transfer must be known: conduction, convection, and radiation. The image on the right demonstrates the thermal interactions that occurs with the wall. The sun emits solar radiation on the external face. Temperature occurs as convection on the external wall. The cavity is filled with insulation, therefore only conduction occurs within the wall, and radiation is emitted off the internal wall. The image on the right is another example of the wall. As you can see, temperature reduces as heat flows from the external to the internal face. No physical testing could be done, therefore a finite element heat transfer analysis was done. This image depicts the 2D cross-section that was used in the analysis. There was a wall tie at every 500 millimeters, and the material is homogeneous along the height. Therefore, the problem was simplified in the 2D cross-sectional plane due to this periodic boundary. The cavity is 150 millimeters wide. Each leaf is 50 millimeters wide. The wall tie is 200 millimeters long, embedded in each leaf. For the analysis, three important material properties need to be known: thermal conductivity, density, and specific heat capacity. As a secondary aim to the project, wall ties had to be identified. The wall ties need to be durable, uphold structural integrity, and ensure fire safety. However, these wall ties causes thermal bridging and allows heat to escape. The identified wall ties were galvanized steel, stainless steel, basalt, and glass fiber reinforced polymer. I'll now introduce the candidate insulation materials. First one is mineral wool made from natural stone fibers. Glass fiber made from silica sand and recycled glass. Jute wool made from jute, loofah, and wool. The loofah comes from recycled coffee bean bags, and the wool comes from old mattresses. Cellulose sourced from recycled paper fibers, from recycled paper, newspaper, cardboard, and other newsprint waste. Perlite, it's a natural occurring volcanic glass that is crushed and when heated forms glass-like pellets. Vermiculite occurs through natural processes and is crushed. Spray polyurethane foam. It's a liquid foam that expands. You get closed cell and open cell. Open cell is a softer foam that expands more, and closed cell is more dense, moisture resistant, and has a low thermal conductivity and therefore more expensive. Expanded polystyrene beads consist of small polystyrene beads bonded by a PVA adhesive. And aerogel, made up of 95% air mixed with gel particles. The list of candidate insulation materials were shortened by removing materials that did not meet cost, sustainability, and sprayability. Therefore, tool is removed because it comes in a panel. Perlite and vermiculite is removed because they are loose film materials. Aerogel is removed because it comes in a vat. Spray polyurethane foam and expanded polystyrene beads are both sprayable. However, they are made from inorganic materials and therefore they are removed, and we are left with mineral wool, glass fiber, and cellulose, which are sourced from natural materials. I compiled the table summarizing all the different material characteristics of the candidate materials. The ones highlighted in green was used in the analysis. The table carries on to the next slide. As you can see, SPF close cell is highlighted. This is because out of all the sprayable materials, SPF close cell has the lowest thermal conductivity. Therefore, it was used to compare with the rest of the insulation materials. This is the table. This table summarizes the material properties that was used in the analysis. A Mediterranean zone in spring in Europe was chosen for the analysis due to the sponsorship's interest in European 3D-PC housing. Therefore, 3-day solar radiation and ambient temperature was selected for Madrid, Spain. I performed a finite element heat transfer analysis in Abacus software. The first thing was to model the 2D cross-section, input material properties, which is mentioned on the previous slide, apply loads, interactions, and boundary conditions. The solar radiation and ambient temperature is applied to the external face. Surface radiation interactions are applied to the internal and external face to take into account surface radiation. And the whole facade is given a predefined temperature to avoid the facade from first heating up. Mesh size, element type, and time step. 4-node linear quadrilaterals were used. 3 mesh sizes were considered, and mesh 2 was chosen because temperature results converged at this size. 1 hour time increments in seconds was chosen, which is achieved by that equation, which is specified by Abacus to avoid false oscillations. And finally, I ran my analysis. There was 4 all-time materials and 4 installations, which makes 16 analyses. Is a visualization of heat flow from the external to the internal place. Results. Firstly, I plotted the average internal temperature per wall tie. This plot shows the occurrence of thermal bridging caused by the wall ties. The higher the thermal conductivity, the greater the temperature fluctuation. As you can see, the more conductive steel ties have greater peaks and minimums compared to the basalt and GFRP wall ties, which have lower thermal conductivities. You can also see that SPF, which has the lowest thermal conductivity out of all, has a more gradual pattern. For a better representation of thermal bridging, I plotted the center and edge point nodal temperatures to show you where these occur. The center point occurs at the point that coincides with the wall tie on the internal face, and the edge point is the furthest point from the center point. If you look at the legend, you can see that all the edge points stack onto one another. This is because at this is the furthest point on the internal face, so minimum thermal bridging occurs here. And if you look at the edge and center point for the basalt and GFRP wall tie, you can see that they also stack onto each other. This is because these wall ties almost cause no thermal bridging compared to the steel ties, as there is a you can visually see the difference in between the center and the edge point. Cellulose, cellulose, mineral wool, and glass fiber yielded similar results. Therefore, one was selected to be compared with SPF. Cellulose was selected. The purpose of insulating a household is to prevent heat from escaping during cold conditions and heat from entering during warm conditions. This relationship is shown by a gradual pattern with minimum temperature fluctuations. This pattern is shown by SPF. However, if you compare all the insulations with an external environment, you can see that all the insulations are good insulators. According to the European Commission, a 1 degree temperature change in heating or cooling can save up to 10% on energy bills. Therefore, any change counts, counts to improving sustainability. Following my results, I conclude that all the insulation materials are effective in reducing heat flow, lower thermal conductivities, reduces internal temperature fluctuations. The material of a wall tie influences thermal bridging. A sustainable material is better than spray polyurethane foam. Sustainable insulations, mineral, glass fiber, and cellulose can be sprayed by an automated system. The selection of an insulation can be determined by other factors such as material cost, availability, durability, and location. And finally, modeling sustainable insulations with 3D PC structures can reduce the energy consumption of heating, ventilation, and air conditioning systems. Again, thank you.